Welcome to our next video on the lathe, which is going to deal with the front of the lathe. We thought that we could do the part identification of the lathe in one video, but as you can see, the lathe and all the parts and so forth, it's almost a language in itself. So we're going to move on over. We did the left side of the lathe, and now we're going to do the parts that are on the front. First of all, we're going to look at where the spindle is and what that does. The spindle is actually on the headstock of the machine, which is mounted on the left. We'll see that in a bit. The bed of the lathe, that's probably one of the most massive parts of the lathe. The carriage, which is going to ride above the bed. The apron, which is the lower front of the lathe. And then the tailstock, you'll see where that is in just a bit. So that's what we're going to cover today. And we're going to move first into the spindle.
What are some of the important parts that we need to know how to identify here?
All right. Also in your headstock, you're going to find the spindle. The spindle is what holds your work holding devices, all right, which consists of your 3-jaw chuck, your collet closure, 4-jaw chuck, face plates, centers. So there's a number of ways to hold your part or fasten your part to the spindle so you can spin it, all right. This particular lathe has a cam lock, and we're going to go into that in a later setup on how to use it. And this is your spindle nose, and you need to be aware of that. And remember, cleanliness is important here. Anytime you get dirt or debris on the faces of this and you try to mount your work holding devices, you're going to have problems later with repeatability. All right?
All right, very good, Don. So where's the bed on the machine?
All right, the bed's one of the important parts of the machine. It goes the length of the machine and your headstock and your gearbox mount to it. All right, and that is this portion of the machine. It also has the ways of the machine. All right, and they go the length of your machine, and your carriage then sits on top of it. So though you can see how important the bed of the machine is. We're going to want to keep it oiled, and we want to keep it clean and free of debris and chips and stuff.
So let me just kind of review if I understand that. So the bed is this whole part right here?
Yeah, it's
and
the whole frame, basically. It's the solid frame.
So it's the whole solid frame, and then the ways, what exactly is the ways, and could you show us that, Jason, close up?
This is the way of the machine right here, and you can see that this one has a triangle shape to it, and then the back one has a square to it. All right, and then we have another set of ways here in the center that also guides the tailstock. All right, these are precision portions of your lathe to help guide the carriage, what carries your tools.
So the ways are what guide this big thing known as the carriage. And someone didn't clean this off very well. I got chips on my hand and oil. So well, hey, I'm over in the machine shop. I feel like a machinist now. But someone should have probably cleaned that a little bit better.
Yes.
Okay. So when you're here, Don or your lab instructor will be inspecting and giving it a white glove treatment. So you better have it cleaner than this.
Let's review a little bit about what Don said about the spindle, and then we'll move on over and review the bed of the lathe. So on the spindle, Don mentioned that it's used to rotate the part. So you put your part in a tool holding device that goes into the spindle, and it's your part that rotates on a lathe, not the tool. The different types of part holding devices that will be put on the spindle for Engineering 153 will include, or may include, a 3-jaw chuck, 4-jaw chuck, or a collet closure. And we'll see these things later on in one of our videos. And then Don mentioned, whenever you're mounting a tool holding device to the spindle, it's essential that all the surfaces be absolutely clean and chip-free. Otherwise, they're not going to seat properly, and you're not going to get the proper repeatability. The spindle, as you saw on the video, it's in the headstock area. It is mounted to the headstock, and there it is right there. So we'll see how to mount tool or part holding devices to this, but this is the part that spins very rapidly on the lathe. The bed of the lathe, as I see here with a red arrow, the bed includes the ways and all the metal structure that goes the whole length of the machine. So this is a very, very heavy portion of the lathe. The ways, there's two sets of ways. There's an outside set of ways and an inside set. The outside set is used for the carriage to ride along, and you can see this big carriage here, and we're going to get into more detail. But the carriage goes left and right along the ways. Also, the tailstock of the machine, which is used for different type of drilling operations and tool holding, that rides on the inside set of ways. So tailstock rides on inside set, and the carriage rides on the outside set of the ways. And the ways are connected and on top of the bed or part of the bed.
All right, Don, that moves us over to the carriage. All right, so the carriage is a big thing with lots of stuff on it. So could you give us like the big parts first and then maybe a breakdown?
All right. The big part is the whole unit is a carriage, and on the carriage sits your cross slide. On your cross slide, you sits your compound, and on your compound sits your tool post, and then.
Okay, it sounds like your leg bone's connected to your knee bone, and so let's go slow. So we have the carriage,
Right.
and then the thing on top here, that's called a cross slide.
Cross slide, yes.
Okay, why is it, what slide? Is something slide on it?
Yeah, if you crank this handle, the cross slide handle, you'll see that the tool can move across the bed of the machine. So that's what will help us establish diameters.
Very good. Okay, so I see with the cross slide that goes in and outward. All right, then you had a name for this again?
This is your compound rest slide, all right? Rest, where I can move this at different angles. We have 2 bolts on either side. You have a vernier scale for your angles. So I can loosen this up and I can rotate this at whatever angle I would like and cut angles on my parts.
Okay. So the compound is used to be able to go in and attack your part with the tool at a given angle?
That is correct.
Okay. All right, we got one more thing to go on top of the compound.
Right. And this will be your tool post, all right? This is where you will take and you mount your tool holder on in order to hold your tool so that you can make cuts, because air won't cut apart, so you got to have some kind of sharp edge to cut down your material. So this is what you will fasten to your compound, and it's a dovetail. We call these are common name is a Dolores tool holder. It's basically 2 dovetails cut, and then they got a wedge that locks it down in place, your tool in place.
So in a subsequent video, we're going to show you how to install a tool on that, right, Don?
That is correct.
All right, so quick review. Let's see if I got it. Tool holder, compound, what? Tool post, not tool holder. Tool post, compound, cross slide, and the whole thing is known as the carriage.
Carriage, right.
Okay.
Let's look at the different parts of the carriage in just a still photo here. The whole item that you see is the carriage, and it's riding on the ways. So the cross slide is the part that moves perpendicular to the ways. Okay, so that's moving toward or away from the operator. On top of that rests the compound slide. Most of the time for Engineering 153, the compound slide will be set and not moved. But it can be moved in and outward with the handle. And this allows the user to attack the part with the tool at different angles. On top of the compound is the tool post, and that's where we're going to mount the tool holder and ultimately the tool.
On your lathe, that also is considered apron as the front of this carriage. All right, it's all on it. You have a hand wheel to move the carriage from left to right. We call longitudinal feed rate direction. We have our feed lever for engaging and disengaging our feed, so we can engage our cross feed and our longitudinal feed.
Okay, hold on right there, Don. You just showed me that with these handles, I can do longitudinal feed and cross feed. But now what's this? Does it do the same thing?
It does the same thing, but it does it under power, so you don't have to stand here and crank the handles. And the pleasure of the use of that is so you get a more consistent finish, a consistent feed rate, which extends tool life and extends finishes and helps hold accuracy.
All right, so this is the power button. And probably depending on which way you turn that, you're either going into the part or longitudinal.
Right.
Okay, we're going to go over that again in a subsequent video. All right, what else on the apron, Don?
There's a half nut lever here, which the 153 students won't have to be involved with. And underneath here is an important lever. This is called your oiler. So once a day maintenance, you should pull this lever at least once a day to oil your machine. We talked about keeping all your ways and everything lubricated. All right.
Now, is that something an Engineering 153 student should do before they start, or should they do it after their cleanup?
Before they start.
Okay, very good. All right, I see the emergency stop. Is that also considered to be on the apron, Don?
This particular one is on the apron, yes. And it is a new emergency stop. We also have a thing called the chaser dial. That's for threading, which the students won't be involved with. And that is associated with your half nut lever. All the way to the extreme right of the machine, or the apron, underneath your E-stop is your on-off switch. You have to pull out and pull up to get this normal rotation of your spindle.
All right, hold on here. This button down here, okay, your hand's in the way of the camera. You have to turn that on to do something?
To get my spindle to turn on and get to your gearbox in motion, yes.
Okay.
So if I pull out and turn up, I can get the thing to rotate in a direction, or I can pull out and pull down and get it to rotate in an opposite direction.
Oh, so there's a two directional thing, yes. And that would either feed you. Well, I don't.
You'll have normal rotation, or you'll have forward and reverse, basically.
And that's for the spindle.
Right.
Okay, great.
Let's review the apron with a still photo. The one item at the very bottom is the oiler. Don mentioned that you should pull that out prior to using the machine, and in that way you will properly oil the different internal parts and the ways on the machine. So you pull that oiler out once at the beginning of each session. On the left-hand side, it's a little bit cut off, but the big black wheel there with a hand grip on it, that's the wheel to do longitudinal feed. This will move the carriage parallel to the ways, either toward the spindle or away from the spindle. The hand wheel at the top is for the cross feed, and that's going to move the tool perpendicular to the ways. The large gear type lever there can be moved up or down, and that will supplant the need for the cross feed hand wheel or the longitudinal feed hand wheel. So this will move the carriage either longitudinally or crosswise. At the very right is the spindle power button, and that's pulled out first and then pushed upward. That'll be what's called the normal rotational direction of the spindle. It can also be pulled out and then pushed down, and that will make it go in the reverse direction. So the spindle can spin in both directions, but there is going to be a preferred forward direction, and your lab instructor is going to review that with you.
Don, I've heard some things about lead screw and feed screw, but I don't know. I feel kind of unsure myself here. What's a lead screw?
A lead screw is what we would use to engage your feed rates, all right, for threading. This top one here where you see this nice, it's an Acme type thread. If we use a half nut lever and we engage that, it'll actually carry it across and it'll give you an exact thread size or thread pitch that you need.
Okay, so that's the lead screw, and it's the same screw as what's over here. Right. All right, so that's called an Acme thread. All right, that's lead screw. What's feed screw?
This will be your feed screw, all right, and that's basically will be under power. As long as your gearbox is engaged, one of the things you look for when you're on the machine, if either one of them are not spinning, that means your gearbox is not engaged. So you need to take a look at why isn't my screw spinning? Because if those lead screw or the feed screw is not spinning, you're not going to be able to power feed on this machine. So if you're not power feeding, something's wrong. If those aren't spinning, you know your gearbox is not in gear. All
right, Don. So this is called the feed screw and this is the lead screw. Now, they will both move the carriage toward or away from the spindle,
Correct.
but they're not both engaged at the same time?
On this particular lathe, no.
Okay. Now, how do we select which one of those we're using, or do Engineering 153 students are always going to use one or the other?
You're always going to use the feed screw, and that feed screw is going to be chosen by the icon that looks like a bunch of threads.
Okay. So we are using the feed screw?
Yes.
Okay. And this is the feed screw. Now, I can see that the top one, known as the lead screw, has, threads on it. The bottom one seems smooth, so how does that get the carriage to move?
If you look at it, there's a keyway cut in it, and there's basically like a bushing in there that slides along inside that rotates and spins a gear in there that does gear transmission in this apron.
Okay, so there's something inside of the carriage that's attached to that keyway that's therefore making this thing move.
Right.
All right, so feed screw, top one we're not going to use, that's the lead screw. Oh my gosh, okay. You're going to be quizzed on this, so pay attention.
All right, let's try to review and get the idea of which one's the lead screw, which is the feed screw, and what they all do. Before we do that, this is a good vantage point to see the spindle on-off power switch. So it's right below the E-stop, and like I said in the last video, you pull it out and push it up for the normal rotation, or pull it out and push it down for reverse operation. Now the feed screw is the lower smooth screw. It has a keyway, which is a slot that's cut into it. I'm moving the mouse along that. You can't see it too well because the keyway is on the bottom, but that engages with something in the, Don said it was engages with the bushing inside of the carriage, and that causes the carriage to move along the ways. Now, if you don't see that spinning, nor do you see the next one, the lead screw spinning, then your gearbox is not properly engaged, and you should stop the machine and investigate or ask your instructor to come over. This lead screw is used for threading purposes, and you have to set your machine up for the special threading operations, which we are not going to do in Engineering 153. So there really should be no occasions that I can think of, unless you're doing a special operation with the permission of your instructor, that this lead screw should ever be spinning. But the feed screw should be spinning if your gearbox is properly engaged. So lead screw is on top. We're not going to use that. Feed screw is on the bottom. That one should be spinning whenever you're using the lathe.
I hear something called a tailstock.
Yes.
Okay, where's the tailstock?
To the extreme right of this machine, you'll see a tailstock sitting here. We refer to this as tailstock. It's on the tail of your machine, right? And that has a spindle on it that moves in and out. All right, so that you can drill holes, you can center drill holes, you can use it to support material with live centers. All right, so you can use it for a number of different things, drilling, reaming.
Can I hold you up right there? Don, this is a stationary thing. So you'd put a drill in here, and usually I'm used to when I'm going to make a hole, I see the drill spinning. This drill isn't even going to spin. How are you going to drill a hole?
Well, we don't want to forget that our part is spinning. So our drills become stationary. Your tools are stationary on this machine.
All right, so at home, if you're using a drill, your part is stationary, your drill is spinning. This is the reverse. Drill stationary, part spinning.
Correct.
Okay, good. All right, so are Engineering 153 students going to use the tailstock for anything in particular?
Yes, they will. They'll use it for center drilling and drilling. They may use it for reaming, depending on how their instructor has them set up and run their parts.
So you're going to get additional information on how to use these various parts. One last thing, and what's very important for identification, is the serial number. Now, Don, usually you think of serial numbers so in case something gets stolen, you can maybe get it back and identify it, but that's not why you need to know the serial number here.
No, the student's going to need to know the serial number because each machine is identified using that serial number. Their work attachments or work holding devices are identified also by their serial number. And their serial number can be found on the end of the bed of the machine, just below the tailstock right here, or over here on this right up over here.
All right, well, let's have Jason get a quick look down there. Can you get that? This 29139 on this machine.
Right.
And
it'll be referred to with the last 3 digits.
okay. So the last 3 digits. Where's the other place, Don, you said?
Up here on these right outs. All right.
Okay.
There's another safety guide when you guys are on these machines.
Okay, so go over with that. This is
Here's another area. If you get confused or you get lost while you're on these machines, you can always refer back to these cheat sheets, we'll call them. And they're guides basically to tell you what you need to look for when you're setting up your machine and different safety precautions that are very important. And it goes, and they have a list of 8, and then you have a list of 4 important safety things. Okay. Back to your original question, John, this is lathe 139. It's the last 3 digits of the serial number.
okay. All right, so 139 is that. So later on, when we do part setup, we have to get the matched 3-jaw chucks that say 139. So Jason, if you just come over here, you can see there's, I guess these would be called 3-jaw chucks over here, and also 3 and 4-jaw chucks. All right, mini 3-jaw collet closures. All right, so if you're using this machine, you have to take the things from 139. Now, there's always a possibility a student put it back in the wrong place. So where would you see the number on these?
All right. Where you would see...
Don't drop that on my foot, Don.
I'll try not to. You'll look for this along this ring. Here, you can see it. It's etched in right here. So on every one of these attachments, you will find it somewhere etched in on the outer face or outer diameter of the work holding device.
Now, Don, I guess I'm a little confused. Why can't I just use any of these? They all look the same to me. I mean, if I go and fix my car and put a new tire on, I don't have to worry about if I took it from this pile or that pile. It all seems the same. Why here is this so important?
All right. For the most part, every manufacturer may have a different type of work holding device for their lathe. Or how they're mounting the work holding device to the tool. So what they've done is they got a universal ring right here. You buy the ring. It has like a counter, the 3-jaw has a counter bore in it. And what we do is we turn a boss on this ring, and it helps locate the chuck on there. And what happens is this faceplate is turned on the machine, so that way it's going to repeat to that machine and how that spindle was designed. So if we take this on and off every time in the same fashion, you'll find that your repeatability will go up immensely.
All right. So these things have been adjusted to be specifically matched with certain machines to give us the best repeatability.
That is correct.
All right. That's it for the setup. And Don has not dropped that on my foot, so mission accomplished. Thanks again. We're going to go to movie 2 just a little bit.
Here's the picture of the tailstock, and there's this big whole unit and the handle there you see on the right, and there's also a spindle on the left that you don't see that goes in and outward. This tailstock is used for drilling operations, center drilling, also holding the part, and some other operations. So this tailstock moves toward the part that is spinning along these ways. And as mentioned in the video, the tool in the tailstock does not spin, but when you take a stationary tool and move it into a part that is spinning, you will get a machining operation. On the ways at the very right of the machine, you'll find the serial number. And that serial number is important because when you're using part holding devices such as the 3 and 4 jaw chuck and the collet closure, you need to be able to get the matched part holder for your particular machine. These are precision matched components, and you will get less repeatability if you do not use the matched serial numbers from this machine with the corresponding part holding devices, the 3, 4 jaw chucks and the collet closure. All right, so that's the tailstock and serial number. Let's move into some questions to just review what we did today. So these are the front of the lathe video questions. You should answer these on a separate sheet of paper and submit these to your Engineering 153 lab instructor. First question. Why are there two sets of ways on the bed of the lathe? Number 2, in what direction does the carriage move when the longitudinal feed wheel is turned? Repeat this question for when the cross feed wheel is turned. Number 3 is, where is the oiler located? How and when should it be used? 4, what's the difference between the lead screw and the feed screw? What is wrong if neither of these screws spins when the spindle is turning? And lastly, where is the serial number found on the lathe? Why is it important to know the serial number of your lathe? Hey, thanks for coming to this movie. Next time you're going to actually see the lathe in live action, cutting metal, chips, and making all kinds of neat things. So until next time, see you later.